When I was high school, young guy, I remember I was thinking, what are thoughts made of? Are they made of words, or were they made of images? What, what were thoughts made of? And I was wondering, and what I wanted to do is to make a helmet that you would wear on the head. And this helmet, what it will do is to record the electricity in the brain. And this helmet will have a projector. This projector will project the ideas, like on the wall. So with this helmet, what I was trying to do is to improve communication. Because I was also thinking that verbal communication was very limited, because we need many words to communicate what I'm thinking. What I'm thinking and what I want to tell you about, I need 1,000 words in order to do that. But if I would have my helmet, then I would just sit here, project my ideas, and in 5 minutes we'll be out of here. And also, because communication, verbal communication, has limits, because I'm trying to explain something and maybe some of you would understand differently. So to overcome this, then my helmet will be something very good. At that time is where my passion started. My passion, which has been with me for more than 40 years, which is a pale passion. It's wrinkled, it's greasy, and I'm not talking about one of my classmates. I'm talking about, I'm going to show you a picture of my passion. This passion, which I have been over 40 years, I wanted to study medicine, so I went into medical school. And I remember the first day that I put my foot in the medicine class. What I would do is to spend most of the time in the research laboratories, because I wanted to learn everything about the brain. So by the time I finished medical school, I have already published a couple of scientific papers about this. I wanted to learn how the brain would behave and how the brain functions. So after finishing medical school, I went to UCLA to do my PhD in neuroscience. And at that time, this is me also, with her, here and here. So in 1976, what we were doing is trying to learn where different functions were in the brain. So the way we used to do it is to insert electrodes in monkeys' brains. And what I was doing is trying to find out where memory, visual memory, was in the brain. So I spent 3 years there doing this, but I really wanted to learn about human brains. So I went back to Mexico to study neurology. I started my residency in neurology. And because of my expertise in research and coming from UCLA, I was offered to be the head of the Department of Neurobiology at the National Institute of Mental Health in Mexico. And I had the opportunity there to get one of these machines that you see here, which now it's a piece for a museum, but at that time it was the state of the art. And these computers that you see here were the first computers that would perform analysis of the brain waves, of EEG. We had to program these machines binarily. They were very old, but it was a time when computer analysis of EEG started. At that time also I had the opportunity to meet this guy who was pioneering the analysis of brain waves, the EEG analysis, the original Bigford who invented this, which is called the compressed spectral array, which means it's to do spectral analysis of brain waves. So with his advice, I was able in Mexico with Mexican engineers in 1983, it was a long time ago, I was able to develop my own brain mapping and evoked potential system. This system, which then became portable, and this system is being still used in 120 labs around the world. This is done for clinical analysis mostly, and it's still working. What we used to do is, well, there you see an EEG and the electrical, the brain activity. And we used to do this brain mapping, which there you see an epileptic foci. And with this equipment, we were able to analyze where the information, where the brain was working, and with a very high resolution, because we were able to track all this spreading of the epileptic foci with 7.5 milliseconds, one after the other. We were able also to do evoke potentials at that time. This is an example of what we called brainstem auditory evoke potentials, where you deliver a sensory stimuli, like in this case an auditory stimuli, and then you can track all the pathway, all the auditory pathway onto the cortex. It has some relays in the brainstem and in the mesencephalon up to the cortex, and this happens in 10 milliseconds only. So in 10 milliseconds, the information from the ears gets all the way to the cortex. We were able to do also visual evoke potentials, somatosensory evoke potentials, and also we were able to do what we call the cognitive evoke potentials, which means that the information gets to the cortex and then it's being processed in the cortex by association cortices. So we were able to do mapping of this cognitive evoke potentials. You see where all the information is spreading along the cortex. And well, in 1985, my first son was born. And I had to bring money home. So besides doing research, I went into private practice. I'm also a child neurologist. So I opened a clinic in Mexico a long time ago, which has been a model of approaching learning disabled children. This Centro Neuropsicopedagógico, which is in Mexico City, and which has been also, it's been for more than 30, 40 years, we have been treating learning disabled and adolescents with learning disabilities in a multidisciplinary approach. So we have neurologists, we have psychologists, we have learning people in there. In 1986 we started this. And this has given me the opportunity also to understand the diseased brain. So I started inserting electrodes in monkeys' brains to see where this memory was in. Then I moved into a clinical research area in the National Institute of Mental Health. Then I had the opportunity to help people and also to understand the diseased brain. So with this on, in 2005, I started a neuroscience laboratory with funds from the Mexican National Council of Science and Technology, because I wanted to develop formulas to really measure what things that children need to understand and to learn. Like in my practice, I see a lot of ADD kids, attention deficit disorder kids. But the real thing about this is that there are no specific methods of seeing if a kid has an attention deficit disorder or not. Because we always relay like in surveys to see if a kid has attention deficit disorder. So many people give them Ritalin or give them drugs, which they don't need. So My intention was to develop a laboratory, scientific laboratory, to develop all these specific objective ways of measuring everything which is related to learning. So with this in mind, I needed a model. I needed a model to understand which are the things related with learning. Because if I don't have a model, then I cannot make science. So this model, which is here, it's a 6-step model that explains what happens in the brain when information gets into the brain and all the way until it becomes learning, or until it becomes, in neuromarketing, buying decision, or which means in politics, voting for someone. So as you can see here, the learning process has to do with attention, to sensory activation, to emotion, to cognition, to action regulation, verbalization, and action. And all the steps have to become one after the other. This happens very fast in the brain. We will see each one of them. But all the cycle takes about 300 milliseconds. It's going on all the time, but you cannot go to this step if you don't go first to this one here. Like, while I'm speaking, and if you are understanding or trying to understand what I'm saying, the first thing that you have to do is what? The first thing is the first step of the pyramid. You have to pay me attention. If you don't pay attention to what I'm saying, if your mind is attending other things, then although I am speaking and my words get into your ears, it won't get into your conscience unless you put attention to what I'm saying. So the first step of this neuropyramid is the attention process. And then it becomes sensorial activation, emotion, etc. So in this model, I will also tell you where is unconscious, where is the intuition. We will speak about this. So while I was making this model, a father of a patient of mine told me, hey doctor, have you heard about neuromarketing? So I haven't heard anything about neuromarketing. So I went into the internet and started to learn what neuromarketing was about. So I had the opportunity to speak with K.A. Pradeep from Neurofocus. It was a long time ago, in 2005. Well, I spoke with him, and I realized that in this area I can provide information with my experience. Because when I started speaking about processing of EEG and spectral analysis and coherence and those kinds of things, I realized that I knew more than him. So I got into neuromarketing. So my laboratory, which started as a neuroscience laboratory for the study of learning, processing children and adolescents, very fast became a laboratory to understand the decision-making process in marketing. So one of my intentions here is to bring you this model, because in this exciting and thrilling new area of knowledge, which is neuromarketing, we need to standardize things. We need to speak the same words. We need to have a model so we can do research and we can do science with this. So this is part of my intention.